Hi everybody, this is Tim Urdan, author of Statistics in Plain English, and in this video I'm going to show you how to run a one-way ANOVA in R. If you are familiar with R, then you should be good to go on this video. If you're not familiar with R, take a look at another video that I created, which is descriptive statistics and getting started with R. So I've already imported my data and I've summarized it, run a analysis to sort of get summary statistics on the variables that are in my data set. That's down here in the bottom left window. Now I need to tell R that some of these variables in my data set are going to be factors, and by factors we just mean that they are going to be categorical variables. So I got this green hashtag sentence that just describes what I'm doing. R won't run this. This is just a description for my own benefit. So we're going to make some of these variables factors. We'll start with gender and we'll run that. And ID is also a factor. And then generation. In my data set, I have data from first, second, and third generation American students. So these are first generation students were born outside of the United States and then moved here. Second generation students were born in the United States, but at least one of their parents was born outside of the United States and then immigrated. And third generation is children and their parents were both born in the United States. So those are the three generations. Now, I'm going to run the ANOVA. Again, these hashtag lines that are in green are just notes to the self, telling me what kind of ANOVA I'm running. I'm going to do a type 3 sum of squares, which is pretty standard one-way ANOVA model. So first I'm going to tell SPSS what my model is, and that is that I'm going to look at family orientation. This is a desire to do well in school, to please the family, and to put oneself in a better position to take care of the family. So it's really thinking about obligations to the family. That's going to be my dependent variable, and then the independent variable is my group or categorical variable, and that's generation, first, second, and third generation. So I'm going to tell R that that's the model that I'm running. I am going to bring in this library, which allows me to run this ANOVA script. And now I'm going to run an ANOVA and using type 3 sum of squares. And down here in the bottom left window, it tells me, it gives me a very quick summary of my results. So generation, this is the independent variable for second and third generation. And the F value is here. The degrees of freedom between groups is here. The degrees of freedom error is here, also known as residuals. And the F value is large. And the P value is 3.903 to the negative 11th factor. So you would move this decimal point 11 places to the left, 0.00000, and so on. So this is going to be a highly statistically significant result. In other words, that p-value is a lot smaller than 0.05. So the result is statistically significant, and now you're ready to wrap words around the results. And you say that the differences between the sample means on family orientation, wave 3 family, are statistically significant. The difference between the sample means was not due to chance, and I know that somewhere that there's a difference between the population means. Now, I don't know which population means differ in an ANOVA with more than 2 groups. All you find out at first is whether there's a difference between the population means or not. To see which population means differ, you need to run a post-hoc analysis. So I'm going to run a Tukey HSD And let's run that and see what we get. Okay, so the Tukey HSD compares each group to each other group. So second generation compared to third generation. We see the difference between the means, and we see the 95% confidence interval for the difference between the means. So that's kind of the range where the difference between the population means is likely to fall. And here is the p-value. So second generation is different from third generation. And because we say second generation mean minus third generation mean, and that produces a positive value, that difference is positive, this tells us that the mean for the second generation group is higher than the mean for the third generation group on our dependent variable. So we can say that the population means of second generation students on family orientation are higher than the population mean for third generation students on family orientation. Now let's compare first generation to third generation, and we see that that difference is also statistically significant, and it's also positive. So the population mean for first generation students is higher than the population mean for third generation students on family orientation. Finally, we can compare first and second generation. We see that that is a positive value, and it is just barely statistically significant. 0.0424 is just a little bit lower than 0.05. So now we can conclude that first generation students, on average, are higher in their family orientation than second generation students. Okay, so we have answered most of our questions. It is also useful to run descriptive statistics on these data so that you can actually get a sense for what the means are. So let's do that. We're going to run this library that allows us to run descriptive statistics. And then we run this line here, summary, and this gives us a summary of our descriptive statistics data. Okay. Now this is limited to the descriptive statistics for the dependent variable. So for wave 3 family, third generation group, there are 297 students in that group. Their mean for that group on wave 3 family is 3.58, and the standard deviation is 0.897, 4, 2, and so on. And then the standard error of the mean is here. See how it looks like a confidence interval. I'm not sure exactly what that means, but I think it might be the range of the confidence interval, but I'm not positive. That would be the confidence interval for the mean of third generation students on wave 3 family. And then you can see the second generation data. The sample mean is a little bit higher than it was for the third generation group. And we found earlier here in the comparison of of second and third generation that difference is statistically significant. And the sample size for the second generation group is 461. And then the first generation group has the smallest sample size, still a pretty large sample, and the highest sample mean, and that mean was significantly higher than it is for first or second generation students. So that's how you run a Oneway ANOVA in R and get post-hoc tests and descriptive statistics.